Hello. Okay. Hello. Hi, I'm audible, right? Okay. Thanks. We'll start in few minutes, 2 3 minutes. Hello. Okay. So maybe we can start. I think around 7 8 people are already here. So shall we start? Okay. Thanks. So hi. Good afternoon. I'm Prashop. Currently, I'm doing my PhD in IEC Bangalore. So every week during this time, 7 to 8 p.m., we will be discussing gate solutions, mostly on signal systems, engineering, mathematics, communications like that. So this week we'll be discussing some miscellaneous topics, especially in engineering mathematics. So we'll begin by solving a question related to what is known as Newton-Raphson method to find roots of f of x. So for this gate EC paper, I think there's a section on numerical methods. So related to that, once in a while questions from these topics will come. So let us begin by discussing about Newton-Raphson method to find roots of f of x. And in the process of discussion, if something is not clear at any point of time, please feel free to interrupt and let me know. And also, like if my voice is not clear, something, please let me know. Okay, so first topic that we'll discuss today is related to Newton-Raphson method to find roots of f of x. So Newton-Raphson method basically is one of the many iterative algorithms that we can use to do a variety of things. For example, we can use this Newton-Raphson method to find roots of a function, or we can use it to minimize a function, maximize a function. There are many applications for that. So first of all, why do we need this method? So these methods, not just Newton-Raphson, in general, any of this numerical method, why do we need them? Why can't we directly solve it? So an example is, let us say we have f of x, which is 7, something like that. So if the question is like, say you want to find the roots of a quadratic polynomial, it is easy. We can use the quadratic formula for that. So what if f of x is cubic? Now, if it is cubic, still it is doable. I mean, we can work around few and kind of factor it out some term and then use some other known method to solve it. But by the time it reaches fourth order, things will get very hard. Like even if it looks not much difficult, like x raised to 4 plus 2x minus 7. So if you want to solve this equation instead, it will be a bit more difficult than what is solving a quadratic. So in general, if we have higher order polynomials, then finding the roots or solving for those higher order polynomial equations, those things will be very difficult. So there is no way to use our existing formula, or like let us say there is something known as quadratic formula for fifth power, for example. There is something like that. So we need to find some other technique to solve these equations. So these iterative methods are an alternative way of finding a root of these polynomials or things like that. The other motivation is that when we think from a implementation point of view, let us say we want to use a computer to find the roots. The computers will basically use these iterative algorithms to get the roots. So with that being the motivation, let us see what is this Newton-Raphson method. So to answer such questions, what we need to know is we just need to know the minimum details about the algorithm. Like we don't need to know too many things. Like we don't need to tell about when will it work or when will it not work. Those things might not be coming for gate exam. But what we need is we should be aware of the fact that there are algorithms like that. So I'm not very sure like what weightage is given to these topics right now. But I have seen questions on these topics in the past, and this is also one of the engineering colleges is what I feel like. At least in the place where I come from, this is not a subject that is taught as part of the core course. So this mostly fall into the category of electives. But this is again scoring. So okay, and I actually don't know what fraction or what weight is given to this topic, but let us for the time being discuss two examples. Like we first discuss equation Newton-Raphson, and then we discuss method on a different method, and then see that question before moving on to the. Okay, this is not there. Huh? Are you very sure? Can you quickly check and let me know what about electrical gate? If it is there for electrical, then I can just show it. It won't take much time. I'm not very sure if it's there in gate. Mm. If it is there, it will come as numerical methods, something like that. So if it's not there for EC or electrical, then we can skip this. We have more questions that we can do, or we can do this just for the understanding point of view later if we have time. So let me just see. Okay, it's not part of EC gate. Okay, then that's good. We can skip this. Let me see. For electrical also, right? EC, electrical, and instrumentation. These three things I need to see. Other subjects are okay. Okay, for instrumentation it is there. So is there anybody here who is from instrumentation topic? EC instrumentation? Right now I was able to discuss a topic on numerical methods, but it's not there for EC or electrical. It's there for instrumentation. So does someone want to discuss these things? Like maybe you can do it at the end, like not right now, but at the end we can do. So yeah, for instrumentation it is there, but for other two, I think EC and electrical, I don't think it's there for this year. Okay, anyways, we can, if somebody is there from instrumentation and if anyone want to discuss about numerical methods, let me know. I can discuss towards the end of the session. For others, I think we can just continue. Okay. So I think for the time being, we can skip this. We can come back later if needed. Okay. This I'm sure it is there in this syllabus. So this is related to complex analysis. Okay. Yeah. So let us discuss a few questions on complex analysis now. Now, I think we had a session like some quite a few time back, like some 3 months back or something, where we discuss some properties and things like that about this complex analysis. For a quick revision, let us see some basic result regarding complex analysis. So, so first is that we define what is known as complex function. So, a complex function is a function of equal to, I mean w equal to sorry, f of z, where w can be complex and z can be complex. So this is how we define a complex function. So we are already very much familiar with what is a real function, how do you define real functions, things like that. So complex function is an extension of real function to complex numbers. So this function f that we have here will take a complex number as the input and will give a complex number at the output. That is the idea. That is how we define a complex function. Now another way of writing the same thing is like this. We know that z equal to x plus jy, where x is the real part, y is the imaginary part, and j is our square root of minus 1. So another way to write this complex function is that this w is also potentially a complex number. So what we can write is that we can write f of z as some real part xy plus j times imaginary part xy. So this is another way of writing the complex function. So this u is the real part of f of z, v is the imaginary part of f of z, and then x and y are again like the real and imaginary part of the input of that. By the way, if anything is not clear, please let me know. So just like the numerical methods, complex analysis is another topic that is mostly it is not covered in the regular max course. So sometimes it will be there, sometimes it won't be there. So I know many people who have told that they haven't learned this during their BTech. So if something is not clear, please let me know. And this is there in the syllabus. Like yeah. So I will not be going to too much details about these things, but just to get the stage clear. So complex function is basically a function of the form w equal to f of z, where z can be complex and w can be complex. And we can write this as a real part plus j times imaginary part. Now, for real numbers, we know how we defining these things, like what is a real, what's the limit of a function, what's a continuous function, what's a differentiable function, things like that. So all those things we can extend to complex functions also. And now I'll be discussing too many teachers here. So we have definitions for limit, continu, So we have our usual definitions for limit, continuity, and differentiability for real numbers. We can extend these to complex numbers as well. And associated with that, one very important term is analytic function. So in simple terms, a function f of z is analytic at z equal to z naught if f of z is complex differentiable at z equal to z naught. So basically, for a real function, if we can find the derivative of the function at a given point, we say that the function is differentiable. Similarly, we can define a derivative for the complex function. And since complex functions are having real and imaginary, the way in which we define the derivative is slightly different. We will not be going to that here. But with whatever definition we use to define the complex derivative, we can do what is known as a complex differentiation. Now, if a function f of z is complex differentiable at z equal to a given point z naught, then we say that the function is analytic at that point. Or in even simpler terms, analytic function means complex differentiable function. That's the idea. And some example, most common example of a complex differential function is polynomial. So like f of z equal to a naught plus a1 z plus etc. a n z raised to n. Then other example is rational function. Like you can have f of z equal to some a z by bz not 0, and a z bz being polynomials. So these are the some examples of. So we can think of it like this. I mean, even though it's not exactly same, these polynomials are differentiable for real functions. So again, rational functions are differentiable. So for complex functions also, complex polynomial functions are differentiable, or we can call that complex polynomial functions are analytic. Similarly, sorry, complex rational functions are also analytic. Of course, denominator should not be zero. Yeah, and these are the basic things. So far, is there any doubt in any of the definitions or anything? So with this, I think we can go to problem solving part. Before, I mean, we need to introduce a theory, but fine. Is there any doubt, any clarification till what I covered here? If something is not clear or I want to explain again, please let me know. Okay, thanks. So let us go to some the. So now we discussed that there is something known as complex function and there is something known as differentiation. What is the next step? Next step is integration. So for complex numbers also we can define a complex integration, and there are many properties there and many ways to do that. We won't be going there. But out of the many result, one so out of this many result, one interesting result and kind of important regarding complex integration is what is known as a Cauchy's integral formula. So the statement goes like this: let f of z be analytic inside and on a positively oriented, simple, closed, smooth contour gamma. There are so many words coming here. I'll explain that. So let's suppose f of z is something that satisfies these properties. Then this integration over gamma f of z by z minus a dz is 2 pi j times f of a if a is inside gamma. So what this statement telling is that in the complex plane we have real z, imaginary z, and we have some closed curve. Now, and there is a point somewhere. So the theorem, there are so many words like smooth. Of course, means smooth in the usual sense only. Now, analytic, like we discussed, a function f of z is said to be analytic if it is complex differentiable. Now, consider a function f of z to be analytic, and where exactly it should be analytic inside and on a curve gamma that we have here. Now, what are the features of this curve? This curve is smooth, smooth in the sense like the usual English meaning smooth. There's a mathematical definition for that, but that's easy to understand. Now, positively oriented. This means we are going in the curve in the anti-clockwise direction. That's the meaning. So the meaning of this. So this is a very important thing. Like if the integration is in the other direction than clockwise direction, this is not the same. It will be different. So positively oriented means going anti-clockwise. Then symbol basically means symbol curve. Symbol curve is a curve that does not intersect itself. For example, this is simple, whereas this is not simple. Simple in the sense that's a definition that we use. So a curve basically means that it is not intersecting itself. Now, closed, smooth, we have a curve that is closed and smooth. Fine. So f of z is an analytic function, and it is and this function is analytic inside and on a curve gamma, which is positively oriented, simple, closed, and smooth. Then this complex integration, the integration over gamma f of z by z minus a dz, this can be written in terms of the value of the function in, in that point a. So specifically it is 2 pi j times f of a. And this is a very useful result to evaluate complex integrals. And many years this question have appeared in gate exams. So so far any questions or clarification? If it's okay, we can move to the solutions. Sorry. Shall we proceed? Okay. Thanks. Okay. So first question is this one. This is a slightly old one, but even newer questions are also there, similar kind. So question is like this: C is a closed path in the set plane given by mod z equal to 3. Then what is the value of this integral? Integration over C set square minus set plus 4j by set plus 4j. What is complex integration? And assume that we are going in the anti-clockwise direction. So in this question, they forgot to mention that, but assume that. Okay. So what do we have? We have this integration over C set square minus set plus 4j by set plus 2j dz. And the curve is mod set equal to 3. So if we see the complex plane, our curve is mod set equal to 3. So that's basically a circle of radius 3 and center 0. Now we are integrating this function z square minus z plus 4j by 2 plus 2j, and we are going integrating over the circle. So suppose that we are going in the anti-clockwise. Generally they will mention in this question, I think they didn't mention that, but yeah. Now what is integration? So The question is clear, right? If something is not clear, something needs more explanation, please let me know. Okay, so what is it? We have it like this. So this is of the form integration over c f of z by z minus a dz, where f of z is the numerator, z square minus z plus 4j, and a is basically minus 2j. It's easy to see that this whatever integration that we have here falls into this category, where the numerator f of z is given by z square minus z plus 4j, and this is basically z minus a, which means a equal to minus 2j, like we have. Now, this point minus 2j, if you see, it happens to be inside the circle. So this point is like minus 0, minus 2j, or can write 0, minus 2. So again, if you see the numerator, f of z is a polynomial. Answer is C. I think yeah, it is C. Yeah, that's good. So f of z is a polynomial function. That means it is analytic, and we can use, and of this circle is basically a example of a smooth contour that is again simple. So this satisfies all the conditions that are necessary to apply this Cauchy's integral formula. So we can apply this. So what is this thing? So this integration over c f of z by z minus a dz is 2 pi j times f of a. This is 2 pi j times f of a means minus 2j square minus 2j, 2 pi j minus 4 plus 6j, or taking the j inside, 2 pi minus 4j minus 6, taking the 2 outside, okay, minus 2j. So this is C. So option C is the correct answer. So any doubt, any clarification here? Is it okay? Shall we move to the next one? Okay. Thanks. So yeah, this is again similar. So what do we have? This is okay. Maybe should I? I think I can. I'll do it at the end. I mean, this is similar to what we did before. There is a different topic that I would like to discuss. So if time is there, we can do this. This is same as that. So we'll come to that. Yeah. So this is the next topic basically. So this is known as Cauchy-Riemann equations. So again, this is a standard theory from complex analysis. So sometimes there will be questions where it will be useful to know this fact. And again, as I mentioned before, this fact might not be taught as a core course in all the BTech programs. So just thought to discuss it here. So Cauchy-Riemann equation is a set of two equations. Cauchy-Riemann equation is a set of two equations that are satisfied by analytic functions. So the theorem is like this: let f of z be an analytic function. Let f of z be u plus jv, I mean u of xy plus j times v of xy, where z is the complex variable x plus jy, and u and v are the real and imaginary parts of the function f of z respectively. If this is true, then that means that these two partial differential equations hold. So what it's saying is that the partial derivative of the real part of this function with respect to x is same as the partial derivative of imaginary part with respect to y. This is the first Cauchy-Riemann equation. Other one is that the partial derivative of real part of function with respect to y is same as the negative of the partial derivative of imaginary part of f with respect to x. Yeah. So dou u by dou x is dou v by dou y, or dou u by dou y. I mean, it's not or, it's and dou u by dou y is minus dou v by dou x. So these two equations together is known as the Cauchy-Riemann equations. And there are other ways of writing the same thing. Like right now, we just wrote it in the xy coordinates. There is an equivalent form dealing with the polar coordinates, r theta coordinates, which I won't be discussing here. But the key point or the key takeaway is that if a function is analytic, then that function satisfies what is known as this Cauchy-Riemann equation. So, is it okay? Shall we continue? Okay, thanks. So now we will use this Cauchy-Riemann equation to solve the next question. So this question is again slightly old, but I have seen some other questions also. So okay, so the question is like this: the real part of an analytic function f of z, where z is x plus jy, is given by e raised to minus y cos x. Then what is the imaginary part of f of z? This is the question. So we have a complex function f of z, that is u of xy plus j times v of xy. It is given that the real part of this function u of xy is given by cos x. What is the imaginary part of the function f of z? So in general, if we have a function and we are given with the real part, there is no way to find the imaginary part or vice versa, because usually there will not be any relation. These will be independent. But in this question, it is given that it is an analytic function. So for analytic function, we know that Cauchy-Riemann equation satisfied. Cauchy-Riemann equation holds. So using that fact, we can, given the real part, we can find what is imaginary part or vice versa. So the question is clear now. Can move to answer, right? Yeah. Okay. So so if f of z is analytic, then we have dou u by dou x is dou v by dou y, and dou u by dou y is minus dou v by dou x. Basically, the Cauchy-Riemann equation. Now, what we have is is given by e raised to minus y cos x. So, what is dou u by dou x? This is minus e raised to minus y sin x. So, we do the partial differentiation of this thing with respect to x. So cos x derivative minus sin x, so we get like this. Dou u by dou x is minus e raised to minus y sin x. Now, by the Cauchy-Riemann equation, this is same as dou v by dou y. So what do we have? We have dou v by dou y is minus e raised to minus y sin x. V is integration over y minus e raised to minus y sin x dy. And here, since the so here integration is over y, so x is independent, it will come out minus e raised to minus y dy. This is sin x times e raised to minus y plus constant. But there's a catch here. So we can say that this v is e raised to minus y sin x plus a constant. But the thing here is that here we are doing a partial integration. We are integrating only over the variable y. So since this integration is considered, x is also a constant. So this whatever constant we have, we don't know whether it is actually a constant or is it a function of x. We don't know that. So this could be a great So since we did the integration partially with respect to y, there could be any term with x or any variable other than y. Those are also constants. What we should write is this is actually e raised to minus y sin x, a function of x. We don't know what is that function of x, but it's a function of x. So this is a important point here. Like once we do the integration, we might think that it is done and just a constant. Not really. This constant could be also a function of x, because for this integration, x is a constant. So what do we have? This vxy is a form e raised to minus y sin x plus phi of x. Don't know what this phi of x is. So sorry for any doubts. Shall I continue? Think I can continue. Yeah. So what do we have? Think some issue with internet. Okay, fine. I think it's fine. By the way, if something is not clear, if I'm not audible, please let me know. So this is what we have for the imaginary part. V of x y is e raised to minus y sin x plus phi of x. Now what? What is the? How do we find we don't know what is this phi of x. So for that, we can use the other Cauchy-Riemann equation. So we have dou u by dou y is minus dou v by dou x. This is the second Cauchy-Riemann equation. So what do we have? It's again u of x y. In the question, it is given that it is e raised to minus y cos x. So dou u by dou y will be dou by dou y of e raised to minus y cos x. This will be minus e raised to minus y cos x. Similarly, dou v by x will be dou by dou x of e raised to minus y. Did we miss any sign anywhere? I think it's okay. Might have missed a sign somewhere. There's a u, there's a okay, fine. We need to do this e raised to minus e raised to minus y cos x. Okay, it's correct. It's correct. Yeah. E raised to minus y sin x plus phi x. So this is same as e raised to minus y cos x plus dou phi x by dou x. Now what we have? We have this Cauchy-Riemann equation which says that dou u by dou y is same as minus dou v by dou x. So equating these things, we have minus e raised to minus y cos x is negative of e raised to minus y cos x plus dou by dou x of phi x, or I can say that this is minus e raised to minus y cos x plus dou phi x. I mean minus inside dou x. This is minus e raised to minus y cos x. So these two get cancelled out. That means dou phi x by dou x equal to 0. Or in other words, phi x is actually a constant. Phi x doesn't depend on x. So phi x is a constant which doesn't depend on x. So phi x is actually a constant. So using this fact, we can now, instead of writing phi x, we can write as a constant. So what do we have? We have v of xy will be e raised to minus y x plus c. This is the answer. Now, we don't know anything more about the question. We don't know what is the value of c. With the whatever information that is given in this question, it is not possible to find a single value of c. It could be any constant. We don't know. So what to do? We need to look at the options. So if you see the options, none of the option has any constant, and we know that v of xy e raised to minus y sin x plus c. Sin earlier cos is it sin? Is sin. Yeah. Yeah. Since there is no constant anywhere, and this part, this whatever we have here, is same as what we have here, we can say that option B is the correct answer. So option B is the correct answer for this question. So any doubts? Any clarification? Is this okay? And for the exam, like there is a trick also, like not exactly a trick, but for this particular question. So it is from the options itself, it is not clear that there is no constant anywhere. So in the first step itself, we know that v is like this, and once we just do the integration, which won't take much time, we can directly see that vxy is of the form e raised to minus y sin x plus a function of x or a constant. So by this much itself, we can easily see that out of the four options, only option B is there, because there is no other option with e raised to minus y sin x. All what we could have is some phi of x, which could be 0. So in this case, it happened to be 0. So without even doing the second part of this question to verify that it's a constant, by the time we reach here, we can already tell that the correct option is option B, because there is no constant term anywhere here. So for this particular question, that's a trick. But in general, like such things can be done here. So yeah. So any doubts? Shall we move to the next question? Okay, thanks. So next one, let us see. Next is slightly different topic. Okay, this is a question. This is again calculus, but it's not the complex analysis. So this question slightly different. So yeah, what is the question? So question is like this. Okay, yes, please.
Before we move on from complex analysis, I wanted
Yeah,
to residue theorem. I wanted to explain residue theorem.
residue theorem. Actually, I can explain maybe after this, or maybe next week I can do one or two questions on residue theorem. Is that okay? So for
Okay,
that,
sir.
we need to define what is a residue, and there are different types. Like there are simple poles, removal, singularity, those things. So those things also we have to explain. So shall I do it next week? Like, is that okay?
Okay, sir.
Okay, thanks, thanks. So next week I'll do at least one question residue theorem. Okay. So yeah. So any other doubts? Any other questions? Shall I move forward? Okay. Maybe is something audible now? Not very good now. Hello, I'm audible. I think my net is showing bad signal here. So
Yes, sir. Yes, sir. You are
okay,
audible.
thanks, thanks. Yeah. Okay. So this question is on calculus. So slightly different. What is the question? So a function f of x is defined as f of x is e raised to x for x less than 1, and log x plus ax square plus bx for x greater than or equal to 1, where x is the real number. Now, given this one, which of the following is a correct statement? Like f of x not differentiable at x equal to 1 for any values of a and b, or is it that f of x is differentiable at x equal to 1 for unique values of a and b? F of x is differentiable for all values of a and b satisfying this condition, or is differentiable for all values of a and b. So basically, we are given with a piecewise definition of a function f of x, and we are asked to find is this function differentiable at the point x equal to 1? Like if it is differentiable, under what condition? Like is it for a single value of a and b, or can we do it for any values a and b? Things like that. So how to solve this question? So let us see how these things are defined. So a function f of x is called differentiable at a given point. By the way, we are back to real analysis. Everything is real now. There is nothing complex here. So a function f of x is differentiable at the point x equal to x naught if limit of h going to 0 minus f of x naught plus h minus f of x naught by h is same as limit of h going to 0 plus f of x naught plus h minus f of x naught by h. Basically, if these two values are same, or in general, if limit of, you can say that if limit of it's going to 0. F of x naught plus h minus f of x naught by h. If this limit exists, then we say that the function f of x is differentiable at the point x naught with the value of the derivative being equal to whatever value of this limit is. That is how we define the derivative from first principles. Now, in this derivative, if you see here, this 0 minus means we are coming from the left side, and 0 plus means we are coming from the right side. So, whatever we have here is known as the left hand derivative, and whatever we have here is known as the right hand derivative. And if a function is differentiable, left hand derivative and right hand derivative should be exactly same. So, that's the idea. So, okay. You mean the answer is option C? Let us see. Let us see. Okay, so next condition is that this is also slightly related but kind of often overlooked. So a function f of, let's suppose that we have function f of x that is differentiable at x equal to x naught. Then the function f of x is also continuous at that point x equal to x naught. So what does it mean is that if a function is continuous, that means limit of x going to x naught f of x exists, or in other words, the left limit and the right limit, like limit of x going to x naught minus f of x is same as limit of x going to x naught plus f of x, which is same as the limit of x going to x naught at f of x. And this thing we call as the value of the function at that point. So if this is true, then we say that the given function is continuous at the point x equal to x naught. And the point here is that if a function is differentiable at x equal to x naught, then the function is continuous at that point. So these two facts, using these two facts, we can kind of approach this question. So for any doubts, and we don't need to use this first principle to solve this question. We just need to know the idea. I mean, what is the left derivative, what's the right derivative, and what are the properties, like LST should be same as RST. These knowledge will be sufficient. You won't be required to directly use this formula to solve this question. So any doubts till now? Shall we proceed? So let me know if there is something new. We can proceed, no? Okay, thanks. So what do we have? We have f of x to be e raised to x e raised to x for x less than 1, and log x plus ax square plus bx for x greater than or equal to 1. Now, one thing to note here is that both of these functions, like e raised to x or the function ln x plus ax square plus bx, both these functions are differentiable. So it is easy to compute the derivative of both these functions separately. Now the question is regarding the differentiability of f of x at the point x equal to 1. So if we just ignore the point x equal to 1, it's very easy to see that derivative of this function f dash x is, this is basically d by dx of e raised to x. So the function f dash x, the derivative of f of x is e raised to x for x less than 1. That is clear because this is the function for values less for x less than 1. It is differentiable, so this is the derivative. Similarly, they say should be careful here for x greater than 1, not greater than or equal to, no, greater than. For x greater than 1, this is our function, and this function is also differentiable. So what we can say, that the derivative of the function f prime x, sorry, derivative f prime x is given by 1 by x plus 2ax plus b. So log become 1 by x, this becomes 2ax, and this becomes b. Yeah. So the key here is that b didn't tell what happens at x equal to 1. If we see here, this is x less than 1, this is x more than 1. We don't know what happens at x equal to 1. That's a question. So for all values of x other than x equal to 1, this function is indeed differentiable, and we can find the derivative like this. Now what we need to find, what happens at x equal to 1. So suppose, let us assume that it is differentiable. We don't know whether it is true, or if it is not true, at some point we will come up with a contradiction. That's fine. So for the time being, assume that f of x is differentiable at x equal to 1. Now if it is differentiable, what should happen? The left hand derivative and the right hand derivative should be same. Or if you see the derivative of the function for the values just before 1 and just after 1, these two values should be same. So the left hand derivative, what is left hand derivative? Derivative of left hand derivative is basically the derivative of the function just before that point x equal to 1. That's the idea of left hand derivative. And in this case, e raised to x is the left hand derivative. So left hand derivative is e raised to x at x equal to 1, which is e. So this is clear, right? Any doubts here? Shall I continue? Okay, thanks. So for this function, the left hand derivative is e raised to x at x equal to 1, which is e. And the right hand derivative is, okay, fine, yeah, thanks. So the right hand derivative is 1 by x plus 2ax plus b at x equal to 1, which if we substitute the value x equal to 1, it is 1 plus 2a plus b. So what it is saying is that if the function f of x is differentiable, if if the function f of x is differentiable, then left hand derivative and right hand derivative should be same. What it means is that 1 plus 2a plus b should be equal to 1. This is one condition, so that the function is differentiable at x equal to 1. So the answer is not C. Answer is not C. That is fine, but we don't know whether it is like, is it B or like, is it not differentiable? Like, will we come up with the condition later on? We don't know, but answer is not C. So it's clear, right? This a plus b equal to e, this alone is not sufficient. We need to have the condition to be like this: 1 plus 2a plus b equal to e. That is the condition that we get from the property of the derivative. Like, we need to have the left derivative to be same as the right hand derivative. So once we compute LSD and RST, we found out that if the function has to be differentiable at x equal to 1, we need to have e to be equal to 1 plus 2a plus b. That's clear, right? Should I continue? Can continue, right? Okay, thanks. So so this much is done. Now what else can we do? So we know that, or we are assuming that the function f of x is differentiable at x equal to 1. So if the function is differentiable at x equal to 1, it should be also continuous at x equal to 1. That is a property. So if the function f of x is differentiable at x equal to 1, the function f of x is also continuous at x equal to 1. And what does that mean? The left hand limit of the function and right hand limit of the function at x equal to 1 should be same. So limit of x going to 1 minus f of x should be same as limit of x going to 1 plus f of x. So what it means is that we have the real line, and this is the point x equal to 1, coming from the left side and coming from the right. Okay, wait, what? How to remove this? Okay, yeah. So we are coming from the left side and we are coming from the right side. Now, the for the region to the left of x, it is e raised to x, and to the right of x, it is ln x plus ax square plus bx. So once you approach this point x equal to 1 from either of the directions, the value should be exactly same. Why we are having that? Because the function we are assuming to be differentiable, so it is continuous at that point. So limit of x going to 1 minus f of x should be same as limit of x going to 1 plus f of x. 1 minus means I'm coming from the left side. So on the left side of the point, the function is e raised to x. So limit of x going to 1 minus f of x is e raised to 1. Basically, e raised to x at x equal to 1. Similarly, this right limit is a case where I'm coming from the right like this. So here, for the right side, the function is ln x plus a square plus b. I think it's not b square, it's b. Yeah, b. And since the function to the right is this one, the right hand limit is same as ln of 1 plus a into 1 square plus b into 1. Basically, I'm putting x equal to 1 in this expression. That's it. So what it means is this means e equal to a plus b. So this is one of the options that is given in the question. So e equal to a plus b. So to conclude, we need to have two things, not one thing, two things. So if the function is differentiable at a point, from the requirement that LST should be RST, we have this condition. Furthermore, since the function is differentiable, it should be also continuous. So we have this condition. So together we have two equations. 1 plus 2a plus b is e and a plus b is e. So two equations, two unknowns. If we do this equation number 1 minus equation 2, we can see that 1 plus a is 0 or equal to minus 1. and putting a equal to -1 here, that will tell us b is 1. So to conclude, a and b have unique values. For what? For the function to be differentiable at x equal to 1. So what does that mean is that for this function f of x to be defined like this function is differentiable at x equal to 1 for unique values of a and b. Unique in the sense we have a equal to -1 and b equal to a plus c. Only for these values of a and b, the function is differentiable at a given point. For any other value of a and b, it is not differentiable. So this is the idea. And so option B is the correct answer. So okay. Any doubts? Shall we move to the next question? I think we have 4 minutes. Okay, thanks.
Sir,
Yeah,
is it a is equal to 1 or -1?
-1, right? Is it 1? Minus only, no? Correct, no? 1 plus 2a plus b is e. Subtracting a plus b is e. So subtracting means 1, 2a minus a is a. Correct, no? It's -1.
Okay, sir. Okay, sir.
Okay, yeah. So any other clarifications? Shall we move to next one? I think 3 minutes only. We don't have time for a big question. Okay, this is an easy question. I can do this. It won't take much time. So shall I discuss this? Okay. So this is a relatively simple question. So the question is like this: a fair coin. By the way, if there is any doubt in any of the questions, please let me know. Okay. So a fair coin is tossed n times. The probability that the difference between number of heads and tails is exactly n minus 3. What is the probability? So question is straightforward. The question is clear, right? We are tossing a coin n times. Each time it could be a head or a tail. We want to find what is the probability where the difference between head and tail is 3. So maybe we can have like some one head and like n minus 1 tail. So something like that. So for having the difference n minus 3, what's the probability? It's a simple question here. So this particular question is very simple. I'll explain why. So in general, like if we are dealing with tossing a coin multiple number of times, that's an example of independent events. And for independent events, the probability of A and B is product of the probability. This is the fact. For in general, this is needed. But to solve this question, it's very easy. So when we toss a coin multiple number of times, what could happen? So one option is that we get head, head, head everywhere. That means we will be having n heads and 0 tails. So the difference is n. The next possibility is that I have one tail and n minus 1 heads. So I can have one tail, remaining heads. So in this case, n minus 1 heads are there and one tail is there. So what's the difference? It's n minus 2. And this is just one of the possibilities of the same configuration. I could also have head, tail, head, head all the way here, or I can have head, head, tail all the way here. All these different possibilities. But for all such cases, whenever we have one tail and n minus 1 head, the difference will be n minus 2. And other possibility, you can have tail, tail, head, head, head. And in this case, we have n minus 2 heads and 2 tails. Difference is n minus 4. These are not the only possibilities. There are those two possibilities here where the same thing happens. And anyway, next one, like again, like we can have 3 tails and 3 heads. Difference is n minus 6. So interesting thing is that if we see the difference here, so in general, suppose we have r tails. If we have r tails, then there will be n minus r heads. So the difference between number of heads and tails is n minus 2r. That is always the case. So the difference will be n minus an even number. It will be n minus 0 or n minus 2 or n minus 3, n minus 6, like that. So the difference of the number of heads and tails will be always of the form n minus 2r or n minus an even number. In this question, we are asked to find the probability in the probability that the difference in number of heads and tails is exactly n minus 3. So if you see here, n minus 3 is not possible. Either it will be n, or it will be n minus 2, or it will be n minus 4, like that. So the right answer is 0. So option B is the correct answer. So any clarification? This is okay?
Sir,
Yes.
if he is asked n minus 4, then what would be the answer?
Yeah, that is different. So if it is n minus 4, we need to find the probability that we have like n minus 4. This is possible if we have like two tails, n minus 2 head, or two head, n minus 2 tail. So hello, still audible now?
Yes, sir, yes.
So yeah, so here we need to first find the probability that we get two tails, n minus 2 heads. So two tails means half raised to 2, and n minus 2 head means half raised to n minus 2. Doesn't matter. And how many possibilities are there? Two tails out of n. So n choose 2. This is just one way of. This is the probability that we get two tails in n. But it could be other way around also. Like it could be two head and n minus 2 tails. So it will be again this thing. And this is the yeah, yeah, that's it mostly. So I don't think it's there. Okay, of course it won't be here. Okay, but yeah, something like this. So we need to find the probability that, did I miss any possibility? No, right? We need to have difference. N minus 4 means we need to have either like two tails and n minus 2 heads. That will give you n minus 4. Or it could be two heads and n minus 2 tails. That way also it could be n minus 4. So these are the two possibilities. And probability of getting two tails and n minus 2 heads is half raised half square half raised n minus 2 n choose 2, and the other is also same thing. So just adding this will give the answer. So what it is like 2 times half raised to n choose 2. So this is approach. Oh, okay, right? I think I didn't make any calculation error here, but yeah, this is the idea. This is okay.
Okay, sir.
Okay, right? Okay, thanks. So any other question? Any other question? In 2019 question 26. What is that? Did I discuss that question? So question 26, 2019. So maybe next class I'll discuss this. Is that okay? Okay. And what topic is this? Anyway, I mean, we can discuss. Next topic is also same thing, like it's signals and systems and engineering mathematics miscellaneous topics. So next week, okay, I'll do this question 2019, question 26, and I'll also discuss what is Cauchy-Sensitivity theorem. So these two things definitely I'll do next week, and depending on the time, we will do some more questions related to miscellaneous and systems. Okay, so any other doubts, any clarifications? If not, we can pause for the day. Is it okay? Shall we pause for the day? Okay, then. Thank you. Thank you very much for attending. Thanks for attending. Okay, I'm going to end the meeting. Okay, thanks.